Hello, everyone, and thank you for joining us today. If you are here for the Memoria Academy Community Lecture, then you are in the right place. As you come in, you might want to adjust your screen and your view to make sure that the one speaking is highlighted. And to do that, you can simply click View in the menu bar at the top of the screen and just choose Speaker. That should take care of that for you. We are so glad that you're here. I'm excited about today's speaker and the topic he'll be discussing. But first, let me introduce myself. My name is Marcy Davis, and I am the head of school at Memoria Academy. We are an online classical Christian school featuring live classes with master teachers for students in grades 3 through 12. I'd like to officially welcome you to the third installment of the Memoria Academy Community Lecture Series. We launched this series a year ago in the hopes of engaging students, families, faculty, and just the broader community with the principles and ideas that have shaped Western civilization. We believe that classical Christian education is transformative in its impact on the lives of students, enabling them to, in turn, make an impact on our world for Christ. By inviting to the table some of the leading minds in classical and Christian education, we hope to continue the great conversation, invoking thoughtful discussion that highlights goodness, truth, and beauty, and that moves us all towards wisdom and virtue. We are very grateful for today's speaker, not only for taking the time to be with us this afternoon, but also for joining us at Memoria Academy. We are so excited to have Dr. J. Wile with us, and he will be bringing his live Berean Builders science classes to Memoria Academy starting in the fall. Dr. Wile has a PhD in nuclear chemistry from the University of Rochester. He is one of the most notable names in K through 12 science education. He is known for his Exploring Creation series, and then more recently for authoring the Berean Builders science curriculum. He is also a faculty member at Memoria College, which is our own Great Books Master's program. I've had the pleasure of hearing him speak, and I know you will be glad that you joined us today. And I'd like to welcome him now as he shares with us a classical approach to teaching science. Dr. Wile?
First of all, this is a classical approach to teaching science, and I'm Jay Wile. First of all, I had some fun with AI. I decided to dive more into AI than I've done recently. And so I asked Google's Gemini to give me an illustration of what it would look like if Isaac Newton was teaching Aristotle physics. And it took a few iterations to get it even close to right. But anyway, I thought that was pretty cool. And so it's neat to think about what that would be like if that could have happened. But the more important thing is when I teach science, I want to teach it in such a way that both of these gentlemen would approve. Because obviously these are two of the greatest minds in history, and probably the greatest mind in science. Some people might say Einstein, but I think hands down it's Newton. I think any kind of approach that we have to teaching science is something we ought to keep people like this in mind. And so with that thought, I want to make two caveats before I start here. First of all, I was never classically educated, and I have never done classical education. I know the theory, but I've never done it. When I educated my daughter at home, I didn't know about classical education. I came to know about classical education because I started interacting with a lot of students who were classically educated. And to this day, I don't know any students who have the breadth of education that classically educated students do. I find them more well-read and more broadly educated than anybody else. I have a lot of respect for classical education, but I've never done it. So when I say a classical approach to teaching science, I'm not talking about pedagogy, and that's the second caveat. I'm not talking about how you're going to do this in terms of grade levels and what you cover and such. That's not something I'm knowledgeable about in the classical framework, so it's not something I can talk about. What I want to talk about is the spirit of classical education and how you apply the spirit of classical education to teaching science. So that's my goal. Just so you understand, that's where I'm coming from. We're talking about teaching science in a way that both of these gentlemen, as well as many of the classical authors, would appreciate. Okay, so with that in mind, let's think about, I can consider 4 things that I think are necessary. And you don't have to be a teacher to enjoy this talk. I'm going to talk mostly as 2 teachers, but a lot of what I'm going to be talking about is just really cool stuff. So whether or not you're a teacher isn't as important as understanding or experiencing some of what I'm talking about. So of the 4 things that I think encapsulate the spirit of classical education in science, the first and foremost is you need to emphasize the wonder of nature. Nature is truly marvelous. And as a science teacher in a science curriculum, you have to emphasize that. So this is what Gemini AI thinks Aristotle might have looked like while he was studying insects. Aristotle studied everything, including insects. He observed everything he possibly could. And here's what he said: every realm of nature is marvelous. So we should venture on the study of every kind of animal without distaste, for each and all will reveal to us something natural and something beautiful. And that's really true. I mean, you look at beetles, and here he is with, of course, this is Gemini AI, but he's got this big smile on his face looking at a beetle. You might not think a beetle is very beautiful, but he did. He thought everything he looked at, including these insects, are beautiful. And in fact, if you study the details of a beetle, you will find some incredible beauty there. And unfortunately, we've kind of lost that in modern science. In modern science, we don't really emphasize that anymore. For whatever reason, for example, modern scientific literature, the actual place where scientists publish, has to be written in a very dispassionate style. The very first time I wrote a scientific paper that was going to be published in the professional literature, my PhD advisor looked at it and said, "This is never going to pass. It's too enthusiastic." So in the end, I had to tone down the enthusiasm to get this a report on my research past the editors, because scientific literature is supposed to be dispassionate, third person, aloof. And unfortunately, we've done that with textbooks as well. Textbooks tend to take on the same style. They write in this dispassionate, aloof way that completely destroys the wonder that we should be communicating about nature. And it's not just Aristotle, it's all sorts of voices throughout history that tell us there's real wonder in the world. So this is Hildegard of Bingen. She was living in the 1100s, and she wrote lots of books. Like a lot of these classical authors, they wrote on all sorts of subjects. But she wrote 2 very important science books. One of them was about the medicinal properties of plants and parts of animals, and the other one was about the human body in general. She was those works were very instrumental in guiding science for the next couple of hundred years. And she was a nun, as Google's Gemini correctly depicts. She was a Benedictine nun, which partly explains why she had so much time to write. But she studied the plants and the animals and so forth, and she appreciated their wonder and beauty. This is what she said. She said, "Glance at the sun, see the moon and stars, gaze at the beauty of Earth's greenings. Now think, what delight God gives to humankind with all these things." That's science. It's delightful. God has given us these things for delight, and we should communicate that. And then, of course, very famous scientists. She's mostly famous as a very early woman scientist, very accomplished woman scientist. But in my field, she's very important because she, her husband, and Henri Becquerel won the Nobel Prize for the discovery and partial explanation of radioactivity. And it's very interesting. Her husband, Pierre, was a scientist before they met. She was a student, and he kind of fell in love with her. She didn't want to have anything to do with him. So when she graduated, she went back to her home country of Poland, and he apparently wrote these very passionate love letters to her that she basically ignored. But in Poland, she got very upset that she couldn't get a professorship because she was a woman. Well, Pierre said, I can get you a professorship if you come back to Europe. So she said, okay, I'll come back to Europe and marry you so I can get a professorship. And so she came back to Europe. They got married. And then, of course, Pierre's scientific career took off right along with Marie. And once again, they were the first married couple to win the Nobel Prize. And apparently, scientists of the time would joke that Pierre's greatest discovery was Marie. And it's probably true. And interestingly enough, they were the first married couple to win the Nobel Prize. The second married couple to win the Nobel Prize was their daughter and their daughter's husband. So it kind of runs in the family, right? And like I said, Marie Curie is known in the field for her work with radioactivity. Some people know that Marie Curie ended up dying of radiation-related illnesses, but most people don't realize why. It wasn't her scientific research that gave her these radiation-related illnesses. She was exposed to more radiation than she should have been in the laboratory, but it was still too low level to make serious illness. The reason she got so sick from radiation is because during World War I, she developed a mobile X-ray unit that could go out on the battlefield. And she learned to drive a car, and she actually drove one of those. There turned out to be 20 made, and they were all called Little Curies. And so these drivers, including her, would drive onto the battlefield and give X-rays to the wounded soldiers in order for them to get better treatment. That's what caused her radiation sickness, because no one understood how powerfully dangerous too many X-ray exposures could be. You know, the patients were only getting one or two. She was getting one every time she gave one. So in the end, that's what ended up causing her problems. But anyway, she says this about science, and I love this. I am among those who think that science has great beauty. A scientist in his laboratory is not only a technician, he is also a child placed before natural phenomena which impress him like a fairy tale. Think about science that way. It should be impressing our students like a fairy tale. And I can't stop this point without quoting this fellow. He is a homeschool graduate. He has his PhD in nuclear physics, everybody's favorite field. And he has already established himself. As you can tell, he's still very young, but he's already established himself in the field of super heavy elements. You may not know this, but we can manufacture some elements. Some of the elements on the periodic table are not natural. They are human-made. One of them is ognesium, which is abbreviated OG. Now, these human-made elements don't exist for very long. They decay away, and their decay chains tell us something about the element. Well, he discovered a new decay chain for one of these artificial elements. So he's already made a discovery in his field, which is really cool. He says this: my Christianity gives me a desire to learn. The world is absolutely breathtaking, and studying the world's beauty fuels my faith. That's the way we should be teaching science. And of course, I try to do that in my books. I try and talk about the beauty. So for example, in one of my elementary books, I spent an inordinate amount of time discussing Leonardo da Vinci, who was truly one of the history's brightest lights. You think of him as an artist perhaps, but he was the scientific voice of his time. And he made all of these wonderful drawings of cadaver dissections that he did. And we still have those original drawings. They have been preserved. And so this is this photo, this image here is one of his drawings of a dissected leg. Here is me quoting myself. This is my favorite thing to do. I'm quoting myself here. In particular, Leonardo da Vinci was fascinated by a person's hands and feet, proclaiming, quote, The human foot is a masterpiece of engineering and a work of art, end quote. Coming from a professional artist, that means something. Why did he think the foot was so amazing? Notice his drawing of the foot on the right. Do you see the tiny strings that travel from the leg to the toes of the foot? Can you guess what they are? Those are the tendons that attach many of the muscles that move the toes to the toes themselves. So think about it. If you want toes or fingers that are strong and can move strongly, you need strong muscles to move them. The problem is if you put those strong muscles in the feet or in the toes, or in the feet or in the hands, then the feet and hands get really big and fat and clumsy. So if you want both dexterity and power, you can't put the strong muscles in the feet or in the hands. What you do is you put them in the legs or in the arms. And then you just extend a cable, the tendon, down to actually do the motion. One of my colleagues calls the human hand and the human foot the cable-operated devices of the human body, because they really are operated mostly by tendons. Now, there are a few muscles in the feet and hands themselves. They control the fine motions, but the strong motions are covered by muscles that aren't even in the feet and hands. That's how beautifully this system has been designed. If we can show students this kind of beauty, that can help them appreciate science, even if they're not particularly science-minded. All right? The second thing we need to do is emphasize nature's purpose. Nature has a purpose in everything it does. And if we understand the purpose, that will point to its source. And Aristotle knew this. He said, for the works of nature, purpose and not accident is especially present. And the end for which they have been constituted or come to be occupies the place of the beautiful. So he recognizes that nature has purpose. We need to teach the purpose of nature. And one of the guys who really focused on the purpose of nature ended up being one that helped us along to the scientific method, and his name was Robert Grosseteste. He was the Bishop of Lincoln, and I asked Google Gemini to give me an image of his famous experiment, which I'll explain in a minute. And I couldn't get Google Gemini to make the mirror look old-fashioned. So basically, here's this bishop from the 1200s using a modern makeup mirror. They had curved mirrors back then, but they didn't look like that. During his time, the 1200s, one of the unanswered questions in natural philosophy was, how does the sun heat the earth? Does the sun heat the earth because it's warm and just give its warmth to the earth? Or does the sun heat the earth by shining light on it? And there were people arguing both ways. Robert Grosseteste gave 5 reasons, 2 of which were wrong, but 5 reasons. The most important one was this one. And he actually did this experiment. He said, take the curved mirror out into the sunlight and use it to focus that sunlight on a piece of parchment. You will burn the piece of parchment. This is an experiment I have my elementary students do. Take a makeup mirror outside when the sun's shining bright and you can burn paper with it. And he said, all the mirror is reflecting is light, and yet that light is warm enough to burn the paper. So clearly it is the sun's light that's burning, or that's heating the earth, not the sun's heat. And of course, he's right. Heat has to have a medium to travel through. There's nothing to travel through in space. So the sun's heat doesn't reach us. The sun's light reaches us, and that's what heats the earth. And along the way, Robert Grosseteste decided that this was really important to his theology, because Grosseteste thought that light was the closest thing in nature to God. His reasoning was it was the first thing he created. God said, let there be light. And so it's the closest thing to God. So when we study light, we have a way of learning about the invisible God. So in the end, he says, okay, the sun's got a purpose. That purpose is to warm the earth. How does it do it? It does it with the light, and that light is an image of God. So he learned the purpose of the sun, which brought him to the source. And he actually said, this is where Aristotle had issues, because Aristotle would come up with an explanation and be fine with that explanation, not want to do anything else. The problem is the human mind is corrupted with sin. This is Grosseteste's idea. The human mind is corrupted with sin. And so if you just think and try and reason a solution, you might not come to the right solution because your mind is clouded with sin. You have to turn your mind away from the sin. How do you do that? By turning it to light. If we use light, we are closer to God. His student, Roger Bacon, we don't know if it's actually his student or just somebody who was influenced by his work, took that and ran with it and came up with a scientific method. He said, come up with an explanation and then test it with experiment. Every experiment I know uses light. You either observe it or you use light or something. So in the end, you're using light. That light is going to turn you away from sin, so you can use that experiment to evaluate your explanation. But once again, it was all about Robert Grosseteste trying to find the purpose of the sun and how it warms the earth. And as a result, he got to its source. James Joule had the same basic idea. James Joule is one of the most important scientific voices in the 19th century, but he wasn't a scientist. He didn't go to college. He was a brewer. His family was famous for the beer they made, and people drank a lot of beer. So in the end, he and his family were very wealthy. As a wealthy man, he had a lot of free time. One thing he tried to do was automate his brewery. That did not go well, but he learned a lot along the way. And one thing he learned was that a scientific fact that had been taught for more than 100 years had to be wrong. Because for more than 100 years, it had been taught that heat was an element, and that element's name was caloric. And when you got warm, it's because you encountered the caloric element. Caloric was made of very, very tiny particles, so it could get through walls, get through the little cracks in walls and so forth. So that's how you could feel heat through a wall. And it was self-repelling. So when a fire made caloric, it would push all the other caloric out. And that's why a fire's warmth spreads. So it makes perfect sense. But James Joule said the problem with that is I can take mechanical energy and I can convert it into heat. And if I double the amount of mechanical energy, I double the amount of heat. That means if heat was an element, I would be destroying energy to make this element. But only God can destroy energy. Therefore, heat can't be an element. It has to be another form of energy. And of course, he was correct. And because of that, because of his wisdom about this, we end up naming the standard unit for energy the joule. Here's what he said about science. After the knowledge of and obedience to the will of God, the next aim must be to know something of his attributes of wisdom, power, and goodness as evidenced by his handiwork. It is evident that an acquaintance with the natural laws means no less than an acquaintanceship with the mind of God therein expressed. The laws give nature purpose, and when you study those laws, you end up learning about nature's source. And this is something I try to do in my books as well. So for example, when I talk about the atom is made of three particles, protons, neutrons, and electrons. Neutrons we're not going to talk about in this talk, but protons are positively charged and electrons are negatively charged. And that's what keeps the atom together, the attraction between the charges. However, the proton is significantly different from the electron. The proton is first 1,800 times more massive than the electron. Also, as far as we can tell, the electron is a fundamental particle. That means it's not made up of smaller parts. The proton is not a fundamental particle. It's made up of three smaller parts called quarks. So these are radically different particles. However, they have exactly as much charge, just opposite signs. So the electron has exactly as much negative charge as the proton has positive charge. If those charges were different by 1/billionth of 1%, all of the large molecules in your body would instantaneously explode. So in the end, the reason we can talk about atoms is because they're perfectly balanced in their charge. So I show students this figure in my book. Obviously, it's fake. But I say, suppose you're walking through the woods and you see something like this, a stick balanced with two sets of stones. Would you think that came about by chance? No. Somebody had a purpose in doing this. They purposely made this balance. So then I say this. Think about that for a moment. Every proton and electron in creation is perfectly balanced so that they cancel each other out, resulting in perfectly neutral atoms. If that balance were not perfect, life as we know it couldn't exist because the molecules in living organisms would just be too unstable. When you see things perfectly balanced, especially things as different as protons and electrons, it's clear that the balance is a result of design. God designed protons and electrons so that atoms would be perfectly balanced when it comes to electrical charge. So the purpose in nature is to have neutral atoms so they can make big molecules to make people and other living organisms. All right, but to have perfectly neutral atoms, you have to have a perfect balance of charge. That perfect balance of charge is the purpose. And we can see that it's so exacting, we can see that its source must be God. So as I said, I try to do it. And believe it or not, this is catching on in modern science. This is really hard to believe, hard for me to believe. About 15 years ago, there was a book published by a very famous atheist philosopher. His name's Thomas Nagel. And he said, look, materialist evolution doesn't work. There's no way it works because it can't explain human consciousness. And since human consciousness is what separates us from the animals, if evolution can't explain that, it's dead. It's not of use. We need to change the fundamental focus of science. We need to change it to purpose, teleology, the study of purpose. Right? So we need to have a teleological outlook on biology. When I read that 15 years ago, I said, you're right, but this is never going to catch on because biologists don't like to talk about purpose. They like to talk about random change acted upon by natural selection, which has no purpose. However, just a year ago, there was a two-part series in the secular peer-reviewed journal Biological Theory that tries to get on the next revolution of biology. That's its goal. This is to start testing the boundaries of what we know biologically. Here's what the abstract from part 2 of that publication says. What is needed, therefore, is an approach to teleology in biology informed by mentalistic concepts such as intelligence, cognition, and intentionality. By abandoning the reductionist aversion to mentalistic concepts in biology in favor of principled and testable frameworks for understanding diverse minds embodied in the physical world, the plasticity and problem-solving competency of the agential material of life can provide fodder for advances in philosophical thought as well as biomedical and bioengineering applications. If you got lost in the jargon there, what he's saying is, this reductionist idea that everything's random chance and filtered by natural selection doesn't work. We need to look at purpose. If we look at the purpose to all of these biological agents that are doing things, we're going to understand biology better so we can better use it for biomedical engineering and so forth. So even 10 years ago, a paper like this could never be published in the secular peer-reviewed literature. No one would be willing to talk about teleology in a biological scientific publication. But that's happened. I see that as a good sign. Does it mean it will actually catch on and become the dominant view of biology? I don't know. But I didn't think this would even happen. So there's a good chance that maybe science is finally catching up to the classical authors who always understood that there was purpose in nature. Okay, number 3, the goal of your science education is not to fill your students' heads with facts. You have to have facts, otherwise you can't do anything, but that's not the ultimate goal. The ultimate goal is to develop wisdom, not just data. And once again, we can refer to Aristotle. Wisdom is a science of certain causes and principles. So in the end, what we need is we need to understand the causes and principles. If you disagree with me that Newton was the greatest scientist ever, then I've got a quote here from the other greatest scientist ever, Einstein. Albert Einstein said this: "I want to know how God created this world. I am not interested in this or that phenomenon, in the spectrum of this or that element. I want to know his thoughts. The rest are details." Now, I need to pause and say that Einstein's God is not the God you're thinking of. Einstein's God is, he actually said it's Spinoza's God, which is like a creator who's created and then either left or is just uninterested in the creation anymore. So it's not a God you pray to or anything like that. It's simply whatever created the world. And it may not even be an omnipotent being. It's just a being that's smarter and more powerful than us. That's what he's referring to God. But his point is, I don't want to just know these facts. I want to know how they work together and how God put them together to actually make the world work. And I try and do this in my books. And once again, I'm going to quote myself, my favorite thing to do. But this is a page straight from the book. I'm talking about both photosynthesis, which is how plants and mostly unicellular organisms, certain unicellular organisms, make food for themselves. And then cellular respiration, which is how we burn that food for fuel. And I say this is all summed up in the illustration on the right. The sun shines light on the earth. Producers, the ones who are making the food for themselves, absorb the light in the chloroplast of their cells and use it, along with carbon dioxide and water, to make glucose and oxygen. Consumers then take that glucose and oxygen and use them to make energy for themselves. This ends up making carbon dioxide and water, which can be used by the chloroplast and the producers, along with more energy from the sun, to make more glucose and oxygen. As a result, the only constant input needed is energy from the sun. Everything else just keeps getting recycled between producers and consumers. All right, now you can be taught all about photosynthesis and how it works and its products and all of that. You can be taught about cellular respiration and all of its products and how it works. And you can even be taught that, yeah, respiration uses the products of photosynthesis. Photosynthesis uses the products of respiration. But until you're given the actual layout, that this is a recycling, that Earth is just recycling all of its biological stuff, and the only thing that's needed as input is light, then you have wisdom. Because you see that Earth is a recycling plant, and it doesn't need any input except the light from the sun. And this recycling happens throughout nature. The Earth recycles its minerals. That's what plate tectonics does. The oceans recycle their nutrients. That's what the tides and the currents do. Heat is recycled. And that's what volcanic activity and so forth does. In the end, everything on Earth is recycled, so that the only thing you really need is input energy from the sun. That's wisdom that we get from the facts of photosynthesis and cellular respiration. And this last one you might not like, but I don't care. Don't leave out the math. You can't leave out the math. You're doing your students an incredible disservice if you leave out the math. When I started teaching, initially when you're a professor, you teach a lot of freshmen. I don't teach freshmen anymore, but when I taught freshmen, I remember in freshman chemistry class, every year I would have at least one or two students say, "Why are you doing math? This is a chemistry class. It's not a math class." Their high school chemistry never did any math. They didn't know what chemistry was, because there's no way you can do chemistry without math. All right. Really, there's no way you can do serious biology without math. Math is everywhere. And it's important because math is a mystery if you don't believe in a creator. This is Dr. Eugene Wigner, PhD physicist who won the Nobel Prize, made one of the stupidest statements I've ever heard. Quote, "The first point is that the enormous usefulness of mathematics in the natural sciences is something bordering on the mysterious, and that there is no rational explanation for it," end quote. This is what most materialist physicists believe. It's an incredible coincidence that math describes the natural world, Because after all, according to Dr. Wigner and people who think like him, humans invented math. We needed to count, so we invented numbers. We needed to trade things, so we invented addition and subtraction. We needed to plot out land, so we invented geometry. Math is a human invention, and if it were a human invention, Wigner is absolutely right. It's a mystery why it would describe nature so well. But it's not a human invention. It's a human discovery. And Galileo said this hundreds of years ago. The universe cannot be read until we have learnt the language and become familiar with the characters in which it is written. It is written in mathematical language, and the letters are triangles, circles, and other geometrical figures, without which means it is humanly impossible to comprehend a single word. So the reason math works so well is it's the language of creation. And if you're going to read the book of nature, you need to know its language. So don't leave out the math. And this can start very early. One thing I have elementary students do in my elementary books is recreate an experiment by Thales in 600 BC-ish. This is Gemini's idea of what Thales might have done, and he didn't use a stick, and I couldn't get Gemini to get that stick out of his hand. He just measured his own shadow, and he had somebody measure his shadow. And when his shadow was the same height as, or the same length as his height, then he had someone measure the pyramid shadow. And that told him how tall the pyramid was, because if his shadow was the same length as his height, then the pyramid shadow would be the same length as its height. Basically, he used ratios. I have my elementary students do that. They don't wait for the sun to get in the right place. They measure, and they do use a stick. They measure the height of a stick and its shadow, and they use that ratio to then measure the height of a flagpole or a tree or something like that. And as soon as a kid understands division, a kid can do that. And you should start that early. That's one of the earliest scientific experiments in history, was Thales doing the pyramids. So it should be recreated, and it can be, and it shows the importance of math even very early on. Of course, this starts in earnest later on. So in junior high school, students start learning about converting between, say, metric and English units, or within the metric system, converting between millimeters and kilometers, or something like that. Well, you can use fractions to do this. It's a method called the factor label method. And once you know fractions, you can use this method to convert any unit, even units you don't understand. As long as you know the conversion factor, you can do the unit conversion. Well, what's really cool about that is that same very technique is used to count atoms. We can't see atoms, but we can count them. And it turns out if I measure the mass of a sample and use this same method, I can tell you how many atoms are in that sample, even though we can't see the atoms. And when I want to do chemistry on them, I can analyze the chemical equation that governs the chemical reaction using that same method. So a method that you start learning in junior high goes all the way through advanced chemistry. That's really awesome. And of course, algebra is used throughout the physical sciences and even some in biology. And then when you do physics, you learn how important trigonometry is for analyzing motion, because trigonometry allows us to do what physicists call vectors. So the point is, math is the language of creation. We can't ignore it simply because students don't like it. It's the language of creation, and we have to be able to do it. So those are my 4 principles. Number 1, wonder. The world, as Dr. Brewer said, the world is absolutely breathtaking. We need to communicate that. 2 is purpose. 3 is using data, but using it to develop wisdom. And then finally, keeping in mind that the universe was written in mathematical language. We should teach in mathematical language. Okay, that's all I've got, so I'll turn it back to Dr. Davis now.
Well, thank you, Dr. Wile. That was wonderful. I appreciate the nod to mathematics, especially. That's my area of expertise. And I will never forget the debates in grad school between me and my classmates over whether math was invented or discovered. And so what a great reminder of how God has built mathematics into all of creation. So thank you for that. And for the rest of your talk, that was fascinating. So we have come to our Q&A time. This is one of my favorite parts of these lectures that we do. And I know that you are ready to handle whatever we throw your way. So I'm going to start with this. One question that I've heard posed with regards to classical education and science is this: why is astronomy the only science to appear explicitly in the 7 liberal arts? Does that mean it's of lesser importance? A quick reminder for our listeners: the liberal arts would include the trivium of grammar, logic, and rhetoric, as well as the quadrivium of arithmetic and its application music, and geometry and its application astronomy.
Well, honestly, I think I've got an answer to this, even though I'm not very versed in classical education. At the time, classical, you think about the classical authors, at that time, the only science that was mathematical was astronomy. All the other sciences were observational. And to the ancients, math was really important. It ranked right up there with logic. Truth is found through logic and mathematics. So the science that had math was the only science that was worth it. As a matter of fact, Ptolemy, who, great classical astronomer, actually said the mathematical sciences can lead us to the theological sciences. So that's what's important. But nowadays it's different. Pretty much every math is mathematical. So I think if the classical authors were around today, they would certainly include physics and chemistry and things like that, because that's the mathematical part.
Well, I think classical education can sometimes be incorrectly labeled as devaluing science. And so I think that perspective is really helpful to keep in mind. At Memoria Academy, we are not just a classical school, but also a Christian one. Can you speak to the supposed conflict between science and faith? And specifically, how do we prepare students to study in programs or under professors who think that these are incompatible?
Yeah, so I got several things about that. I mean, the first thing I would say is this is a manufactured tension, a manufactured fight, because it isn't. And in fact, this idea that somehow science and faith are in conflict is very, very new. It's throughout the history of science, even before Christianity, science and faith walked hand in hand. I mean, the classical authors talked about the divine all the time. I don't know exactly what they meant by that, but they talked about science like Ptolemy. Mathematical sciences lead us to the theological sciences. And of course, once the Christians came on the scene, the Christians made the scientific method. And there's no scientific historian who will debate that in a significant way. You can argue specifically who was the father of the scientific method and so forth, but everybody agrees the scientific method developed in one place: Christian Europe. And in my mind, it was because specifically they needed something to get away from the sin that affects the mind. So in the end, this is a manufactured thing that's relatively new. And it was very common, even up to the early 1800s, for people to praise God and put poems about God and so forth in their scientific papers. So this idea that there's a conflict is relatively new, and it's false, because in the end, science works very well with faith. Every scientist thinks like a Christian when they go into the lab, because every scientist believes that the experiments they do are going to follow laws. Well, it was the Christians who told us why nature follows laws, because it was made by a God, law-giving God. Christians were the ones who said we should look for scientific laws. So even if you're not a Christian, you think like a Christian when you're looking for scientific laws, because that's what Christians did. And on a personal level, I was an atheist until I learned enough science. Once I learned enough science, it was clear that there was no way that you could explain this world without some sort of designer. So that led me to a position of some sort of deism or theism, some sort of creator God. And that made me look more seriously at the issue, and I eventually became a Christian. But I wouldn't have even believed in God if it hadn't been for science.
And what advice would you have for maybe some of our students who want to study science at the college level? Maybe they're
Yeah.
going to a secular university. How do they approach that in the classroom?
Well, there are a couple of things I'd say about that. One thing, for example, my daughter wanted to go to a secular university, and I let her, but since we were footing the bill, I had a couple conditions. And one of those conditions was you had to be actively involved in an on-campus Christian fellowship group. Not just going to church, that's important, but you're going to be facing lots of adverse conditions, especially on a secular campus. You need a support system that's more than a church. So you need an on-campus Christian fellowship group that is made up of people who have already had that professor and can tell you how they dealt with that professor, right? So that's, I think, very important. The other thing that I would say, and I don't want to upset anybody, there are certain organizations that try and say, if you can just answer every question, you're going to keep your faith. So they train you. Okay, here's the atheist question. Here's how you answer it. Here's the other atheist question. Here's how you answer it. That doesn't work because there will always be questions we can't answer. There is mystery to the Christian faith. I don't understand the Trinity. That's a mystery. So we don't have answers to everything. What we have to be comfortable with is looking broadly and saying our faith gives us more answers than it gives us questions. And not having faith would face us with more questions than we have answers. So don't get hung up on one or two things you can't answer. Look at the broader picture. What are the big answers your faith gives you? That always outweighs these little answers you can't give to these things that, and like let me give you a very concrete example. When I was in university, I was taught as fact that 98% of the human genome was filled with junk DNA that did nothing. And so, of course, my atheist professor said, why would God create a genome that was 98% junk? I had no answer to that. Well, the answer is there isn't 98% junk. In 2005, we finally learned that more than 80%, probably up to 100%, but at least 80% of the genome's functional. So in the end, they were using bad science to come up with this question. That happens all of the time. So you have to be willing to set certain questions aside and think about them and hope we can find a resolution and so forth. But think about the bigger answers that your faith gives you.
Well, that's very helpful. Let's switch gears a little bit and look at modern education. We know there's a huge emphasis on science, technology, engineering, and mathematics, better known as STEM. Has this emphasis benefited students in the discipline of science?
I don't think so. I don't think it has at all. Because in the end, modern science is more like job training. And of course, if you're doing job training, then STEM makes perfect sense because a lot of jobs are going to be STEM related. And so if you get trained in STEM, you're going to be better at those jobs. But that's not the purpose of education. The purpose of education is actually to turn ourselves to truth and beauty, but it's to create really good people, good citizens, people who will contribute to society in some positive way. And you don't do that by just teaching skills. You do that by teaching philosophy and teaching ideas and teaching what's truth and beauty and how do you seek it. Now, along the way, you'll gain plenty of skills, right? But in the end, this whole idea that I'm going to focus on STEM or I'm going to focus on this or that, that's just job training. And any industry can do that better than any school can.
Very true. And as classical educators, we always go back to a liberal arts education. That's what it's designed to do.
And I'll tell you practically, when I was a professor at Indiana University, we would look for graduate students, not from these, obviously we would take someone from MIT and things like that, but the most important university we would always look at first, if we got an application from someone from St. John's University, that's the first person we'd look at. And St. John's University has one degree. And it's just a liberal arts education. Those were the people who could really learn everything. And so practically speaking, a liberal arts education in the end produces the best of any student, whether we're talking about nuclear chemistry or something else.
That's great. All right. Well, another major emphasis in the realm of science is AI.
Yeah.
I'd love to hear your thoughts on AI, both from a scientist's perspective as well as an educator.
Wow, I give a whole talk about this. So whittling it down a little bit. As you can say, I like AI. I used AI to make a lot of those images. Some of them were more realistic than others. But AI can be a great tool. So let me just give you a couple of examples. I'm writing another book, the voices in my head keep talking, so I have to keep writing. So I'm writing another book. And, getting a little older in years, I remember reading something, but I can't think of the reference anymore. So I'll just go on to Gemini and ask, what's the paper that talked about the first example of, now I can't even remember the name of it, not gene editing. I don't know, but it's the process by which a cell actually edits the information coming from the genome. And so I didn't know, I couldn't remember, but AI gave it to me right away. So then I could cite the authors properly, cite the paper properly, and things like that. So it helps us remember things that we've forgotten. Also, there are times where, for example, when I did that AI thing about Hildegard, it brought up her as a nun. I didn't know she was a nun. So I asked AI, was she really a nun? And it gave me references to, yeah, she was actually Benedictine monk. And as an actor, when I do Shakespeare, there are lines I just don't understand. So one of my favorite examples is I played Ross in Macbeth. And there's a point where Ross says, "An hour's age doth hiss the speaker." No idea what that means. But if you ask AI, what does that mean? It'll tell you. It means that things are changing so quickly that news that's only an hour old is now wrong or is now out of date. So if you talk about something from an hour ago, you're going to get booed. And so I had no idea what that meant. And if you're acting, you can't say the line unless you know what it means, right? So that's another example of how great it can be. Of course, on the other side, it can be bad. From an educator standpoint, it can be bad because students can use it to cheat. I know a lot of schools, including the physical Memoria Academy School, that's going back to blue books specifically because of that. Exams now have to be written back out on paper in the blue book so that they can't use AI to cheat. And I think that's actually a good thing. I actually think writing is a skill we're losing, and we should probably do that anyway. So AI is a big source of cheating. And of course, you try to use AI to detect AI, but it isn't really good. So as an educator, you do have to think about that. You do have to think how can I keep the students from using AI to do the work that they should be doing? How can I get them to use AI as a tool for what it should be used, but not to replace what you should be doing? Because honestly, like I teach a Memoria College class we could go through the great books of science, and honestly, a student could ask Gemini, what were Newton's 3 laws and 6 corollaries in his Principia? And it would tell you, it would summarize his 3 laws and 6 corollaries, and you would never have to read, But that atrophies your mind, because reading the original work, even though it's hard, is actually more beneficial intellectually than reading some summary that's cold and stale and so forth. So I do think you have to figure out ways to keep that from happening. But overall, I do find it a positive tool. Now, I will say that, obviously, because it's so good at collecting information and finding patterns and so forth, it can be used for very bad things, much worse than cheating. And that has to be thought about, too. And I do think probably all countries are not moving fast enough on that front. But I will say that I think AI is probably the greatest test for whether God really does exist. I really do think, because if you can make an AI that can actually think like a human, then there is no such thing as the Imago Dei. We were given God's image, and one of the things that allows us to do is think. Right? What AI currently does is not think. It collates a whole bunch of information and searches for patterns. Yeah. But if you could actually make an AI that thinks, that would challenge my faith a lot. because in the end, that means we're all just reductionist. If AI can do what I'm doing in my head, that means my head is just electrons moving around too. So
would you say the most important thing for parents who are listening or for teachers would just be to aware and to plan ahead for ways to mitigate this?
yeah, well, yeah, and I think ignoring it is wrong because the kids aren't going to ignore it, and they shouldn't. You're going to be lost in the next generation if you don't know what the next generation's tools are. So I do think, but I think parents have to learn it to some extent. Now, whether they learn how to use AI or whatever is something different, but they have to learn it enough. Parents or teachers have to learn it enough so that they can make their students use it for what it's intended for and not for what it's not intended for. So I do think you have to think about that. And I've done things like there's a thing called you can silver bullet. It doesn't work as well as it sounds. But if you write a problem and include some white text, you don't see the white text on a white background. If someone's copying and pasting, they may not notice that white text. And so for example, I've done this. I've said, explain this. And in white text, I've said, and use the phrase intuitively obvious to the most casual observer. And that was the white text. So and I had a couple of students come back with something that had intuitively obvious to the most casual observer. So that means they were using AI because they copied and pasted. So I do think, teachers should know enough about AI to be able to help students learn how it's useful and to protect themselves from students using it wrongly.
Well, besides AI, some other things that are in the news a lot in the world of science would be the idea of climate change.
Yep.
What do you believe should be a classical and Christian approach to topics like global warming and climate change?
So we were given creation, and we were given a mandate to have dominion over creation. And we think of dominion as a bad thing, but dominion actually involves caring. When you have dominion over someone, that you're in charge, but you care for them. And in the same way, we have dominion over nature. We're in charge. We can use nature, but we have to care for it. So as Christians, we should be worried about caring for nature. The problem is nature includes human beings. And here's your problem. Yes, carbon dioxide is increasing in the atmosphere. And yes, temperatures are going up a little bit. We can't really tease out now how much is human and how much is not human. I know that the common phrase is that it's, 90% of scientists agree it's mostly human caused. That's not what the scientific literature says. The single most important parameter in all of climate change is called equilibrium climate sensitivity. It tells us how much temperature will go up for every doubling of carbon dioxide. Right now, we know that number is somewhere between 0 and 5. So somewhere between 0 degrees and 5 degrees is the increase when you double constant carbon dioxide. Obviously, there's no scientific consensus on how bad climate change is. Now, if you look at everything that's being said that needs to be done to mitigate climate change, all of those things make energy more expensive. If that were the end of the story, who cares? The problem is you can make a direct correlation between energy prices and human death, especially among the elderly. And this has been shown over and over again. Every country, whether it's the developed world or the undeveloped world, as energy prices go up, especially older people pay with their lives. And so the question is, how many old people are you willing to kill in order to fix this climate change crisis that may not even exist? And honestly, that may sound like hyperbole, but that's it. And right now, I don't think the science is solid enough for us to start killing old people. Now, I do think that we should be investigating clean energy, and if clean energy could ever be just even the same or just a little more than the traditional energy, then obviously we should go for it, because obviously we should stop increasing the amount of carbon dioxide in the atmosphere. But right now, every time we replace coal with solar power, people die. Because in the end, energy becomes more expensive and less reliable. And there's nobody who knows the literature who disagrees with that, because that's just raw data. So I think you have to be very careful. And I'm a big fan. There's an approach called use it all approach. And that is use renewables where you need to and where you can, and keep researching renewables to try and get it cheaper, but still use the old stuff to save lives.
That's a helpful correlation to make. I
Yeah.
appreciate that. All right. Question that all inquiring minds want to know. What do you think happened to the dinosaurs?
Oh, so now I'm a young Earth creationist, and I realize Memoria Academy has a diverse view, and I have no problem, unlike a lot of my fellow young Earth creationists, I don't have a problem with Christians who have a different view. As a matter of fact, I don't have problems with Christians who have C.S. Lewis's view. C.S. Lewis is a theistic evolutionist. God created through evolution. That is clear in all of his writings, and also his son-in-law, his stepson Douglas Gresham confirms. Yeah, that's exactly what Lewis believed, that evolution was the instrument by which God created. I have no problem with that. I know some of my fellow young Earthers would say that those folks are compromising in some way. I don't think C.S. Lewis did a lot of compromising. But anyway, but as a young Earth creationist, I think dinosaurs were on the ark because they were land animals. But when they started repopulating the Earth after the flood brought a lot of climatic changes. In the young Earth view, the Earth was all one at one time. All the land was in one place, not exactly Pangea, but kind of like Pangea. And because of that, the Earth was tropical. All the land was tropical. And we know that based on our best climate models, if you make all of the land in one place surrounded by sea, you're going to get to the tropics almost regardless of latitude, unless you're really far north or south. So we think that the climate was one thing before the flood and very different after the flood. And as a result, there were some animals that could not adapt to the changing climate. And so that's what happened to the dinosaurs. They were very specialized already. To warm climates. So in the end, they just couldn't survive the changing climate. And if you're wondering how dinosaurs got on the ark, please understand, if I take all of the dinosaur skeletons we have and average them, the average size of a dinosaur is the same as a German Shepherd. So we obviously didn't, and also the older they got, the bigger they got. So of the Apatosaurus type dinosaurs, you might call it Brontosaurus, but that's a mistake. There's no such thing. But the ones with the big tails and the long necks and so forth, the big ones were very old. Obviously, you wouldn't put a very old one on the ark because you want them to reproduce anyway, so you'd put a young one there. And so once again, the average size of a dinosaur is a German Shepherd, so there would not be any problem with them having room on the ark for that.
Well, that is fascinating. Equally fascinating question here from a student, hailing from a student. Is there evidence for the existence of alien life forms?
Oh, that's a great question. My answer to that right now would be no. Obviously there are some videos that supposedly aircraft pilots have seen and so forth that are hard to explain, but I've not seen any serious evidence for alien life. But I don't discount the idea that there might be alien life. I would think this alien life would probably not be rational life. It probably wouldn't be life like us with the Imago Dei, because then we have issues about how does atonement work and so forth. But, if somebody discovered a fish swimming in the methane lakes of Titan, that wouldn't surprise me at all. God is a creator. Why wouldn't he create elsewhere? And so I wouldn't be surprised if there's alien life. What would surprise me is if it was rational like us.
All right. Well, those are great answers. We're going to end our Q&A here with how we always conclude our community lectures, and that is with a speed round. So just feel free to answer quickly. You don't have to go into too much detail if you don't want to. So we'll start with, what is your favorite book? Outside of scripture, let's say.
Yeah. Don Quixote.
Okay. Favorite book that you've written?
My chemistry book, Discovering Design with Chemistry.
Okay. Can you name a book you're currently reading, not for work, but for pleasure?
Yes, I've got several. Because I'm one of these people that reads many at once. But right now I'm reading Galileo, which is a fantasy book in the Shannara series, in the first Druids of Shannara. That's my fun book that I'm reading right now.
Great. Well, all of our high school science courses that we offer here at Memoria Academy are lab sciences. What is your favorite high school lab experiment and why?
Oh, wow. That's a really good one. Uh, I'd really have to think about that. But I guess the one that comes to mind right away is when you simply take purple or red cabbage, depending on what you call it, and kind of mash it up in liquid, it turns color. And once it depends on the pH and once you add different like acids or bases, it turns different colors. So you can go all the way from kind of a really dark green to a blue to a yellow to a purple to a red, all depending on what you add. So I love those, the changing colors that can occur. And I've used that in theater as well. So I've used that like when we make potions for like Jekyll and Hyde, we use that.
Well, that's great. What would you say is the most exciting scientific development of your lifetime?
Of my lifetime. Boy, I think probably figuring out of my lifetime. Oh yeah, that's right. It'd be my lifetime, so that wouldn't be that, would it? Boy, that I would think so. The expanding universe. Well, no, that was before my lifetime too. Isn't that terrible? Yeah, for my lifetime, it would probably be molecular biology.
Okay.
How biology has turned from less of a descriptive science and more of a molecular science.
And outside of nuclear chemistry, what do you do for fun?
I scuba dive. Love to do that. Of course, I'm in a landlocked state, so I don't do that a lot. I love to read, and I play video games.
Which
I'm a
one?
gamer.
What's your favorite?
My favorite game is the Fallout series.
Okay.
So the Fallout series is post-apocalyptica, and you're trying to survive in a post-apocalyptic wasteland, and there are currently like 5 that are out there, and they're all wonderful.
That's great. Well, last rapid fire question here. If people want to hear more from you, where should they go?
If you want to learn about my curriculum, you want to go to my publisher's website. My publisher is Berean Builders. Remember, there's Paul went to the Bereans who checked everything against Scripture. So BereanBuilders.com. If you want to read my blog and hear my thoughts, that's drwile.com, and it's just DRWILE. Not
Dr.
you don't
Wile.
spell out doctor. Yeah.
Okay. And I know you'll be at the you'll be speaking at the Great Homeschool Convention in South Carolina next week, and several of the other ones there. And Memoria Press will have a booth there. I'll have a booth there with the Academy. So if they're in the South Carolina area, they can come listen to you next week. So, well, Dr. Wile, it has been such a pleasure having you with us this afternoon.
Well, it's been great.
We so appreciate your passion for science and for education. What great reminders you've shared with us about the glory of God evident in his creation and how we can best approach this subject with our students. So thank you for a lifetime of excellent work and for taking the time to be with us today.
It's been a pleasure.
On behalf of Memoria Academy, I'd like to thank everyone who joined us for today's lecture. I'd also encourage you to visit our website at memoriaacademy.com to learn more about our live classes with master teachers like Dr. Wile, though, like you mentioned, if you want to sign up for one of his classes, you better hurry. They are just about sold out. Registration for the 26-27 school year opened a few weeks ago, and many of our classes are already full, but we've got lots of other great courses to offer, as well as a diploma program for high school students. So please visit us. Visit our website or reach out to our office at memoriaacademy.com if we can be of any assistance. Have a great evening, and we hope to see you in the fall for our next installment of the Memoria Academy Community Lecture Series. Thank you.